In this lesson, we're going to talk about the difference quotient, which is kind of a updated, sophisticated kind of slope formula. Now, the slope of a line is always the same, but a lot of functions are not straight lines, and they have a slope that changes depending on the value of x. Here's one, and you can see that for this parabola, if you look at the left side, it has a negative slope, and if you look at the right side, it has a positive slope. So clearly the slope is not the same everywhere on this graph. It's changing. And we can use the slope formula to calculate the slope at any x value on any curve, and when we do that, it's going to be called the difference quotient. Now, I'm going to pick a point here called x comma y, and I'm not going to call it y actually, I'm going to use f of x. And then I'm going to pick another point here, and I can't call this one x because I've already used x, but what I'm going to do is I'm going to say whatever little horizontal distance there is between those 2 points, let's call it h, and then the x coordinate here will be x plus h, and the y coordinate will be f of x plus h. So our function is f of x, and so for our first point we use x comma f of x, and for our second point we use x plus h comma f of x plus h. Now this is still x1 y1 and x2 y2, it's just that they look different now. So when I plug these into my formula, y2 minus y1 looks like this, y2 minus y1, and on the bottom x2 minus x1 looks like this. So this is x2 minus x1, and the only thing we really can do to this to simplify it is to combine like terms in the denominator. Now that is the difference quotient, and I know it's not pretty, but it's really not as hard to handle as you might think it's going to be. There's a little algebra involved, but hey, you know, that's what makes it interesting. So let's take a look at a couple of difference quotient examples. So the difference quotient is a way to find the slope at any point on a curve, and that's all it is. It's really just a fancy slope formula. But like I say, you do not have to know all of what came before in order to work the difference quotient problems. I just wanted you to see why the difference quotient is even in the textbook. And now you know basically what its purpose is. Okay. You will see this again in calculus. If you go into calculus or business calculus, you will see the difference quotient again. It plays a big role in Calculus 1. Now, here's the difference quotient one more time, and here are the steps that you're going to use to find a difference quotient. Step 1, find f of x plus h. Step 2, subtract f of x plus h minus f of x. So this is just going to be a bunch of terms, and f of x is a bunch of terms that you will know. And so that's an easy step to do. And step 3 is to put h in the denominator and reduce. So you can see, first you have to know f of x plus h, then you have to do the subtraction, then you have to do the h in the bottom. Okay, here we go. Find the difference quotient for f of x equals 5x plus 2. Now step 1 was to find f of x plus h. So it's going to be 5 times x plus h plus 2. See, all I did was I took out the x and I plugged in an x plus h, and when I distribute, this is what it looks like. This is f of x plus h. Now for step 2, I have to do f of x plus h, which is 3 terms, minus f of x, which is 2 terms, and it's going to look like this. F of x plus h minus f of x. And notice I had to put f of x in parentheses because I have to subtract everything that belongs to f of x. Now, if I distribute that minus sign, it becomes minus 5x minus 2, and when I combine like terms, I see that my 5x's cancel out, and my 2's cancel out, and all I have left is 5h. Now that becomes important later, that everything that didn't have an h in it canceled out. So the subtraction step leaves us just the h term. So for step 3, I have to take that answer and put h in the bottom. And you can see that the h's are going to cancel out, and I have just 5 left. Now if you know anything about the slope-intercept form of a line, you know that 5 is the slope of this function, and that's what we got here. See, I told you that the difference quotient is just a slope formula after all, so it works. There we go. Now let's find the difference quotient for f of x equals x squared minus 3x plus 5. So this function will not graph a straight line. This would curve. So the slope is not going to be just a constant number like it was in the last example. So step 1 is to find f of x plus h. So I take my function and I replace the x with x plus h. So it says x squared, I make it say x plus h squared. The function says minus 3x, so I make it say minus 3 times x plus h. And then the third term is plus 5. So these three terms I have to simplify. Let's multiply out the x plus h squared. Now we've squared binomials before, so you know that we have to do x times x, and the middle term will be x times h times 2, so 2xh, and the last term will be h times h, so h squared. Now distribute your 3, minus 3x, and minus 3 times h, and then your plus 5, and look at all the different kinds of terms. Not one of them is like another, so we can't combine anything. Now for the subtraction step, I have to do all 6 of those terms minus the original function, which is here. So this is f of x plus h, and this is f of x. And now I'm going to distribute this minus sign. So that's going to give me minus x squared plus 3x minus 5. And now when we go back and combine our like terms, we'll see the x squareds cancel each other out, the 3x's cancel out, and the 5's cancel out, and the only things that are left are the things that contained an h. And now for step 3, I put an h in the denominator and reduce, and that's going to leave us 2x plus h minus 3. Now it's really important that right here in step 2, the only thing we get out are h terms, and all the other terms cancel each other out. Okay, in both examples we saw that when we did the subtraction step, all we had left over were h terms. So we can use that as a shortcut. From now on, instead of actually doing the subtraction step, all we're going to do is pull out the h terms, because we know that when we do the subtraction, that's what we get. So this time, let's take the shortcut. Find the difference quotient for x squared plus 7x minus 3. So first we have to do f of x plus h, and that's going to be x plus h squared plus 7 times x plus h minus 3. And now we have to multiply this out, so our 3 terms we get are x squared plus 2x plus h squared. Then I have to distribute the 7 here, and then I have to do minus 3. Okay, now step 2 would be to do the subtraction, but instead of writing out all those terms over and over again, I know from experience that the subtraction step is just the h terms. So 2xh plus h squared plus 7h. And see, I didn't have to do all that writing out and distributing like we did in the last step, in the last example. Alright, now, step 3, I have to put that answer over h and reduce. So I'm going to get 2x plus h plus 7. Now, I don't know if you might be wondering, well, how would this help me find the slope? Well, in calculus, you put the 2 points so close together that the little h difference between them is 0. And then, all you have left is a formula that contains x, and you plug in whatever x value you want to know the slope at, and there you have the slope. So it's pretty easy to use, but in algebra we don't have to use it that way, but in calculus you would. So I know some of you will go on and take calculus, and you've had just a little preview of a really important idea in calculus now. Okay, one more example together. Let's find the difference quotient for f of x equals 2x squared minus 6x minus 3. Alright, f of x plus h minus f of x all over h is our difference quotient. You do not have to memorize this for my class. Anytime I give you a test, this would be given to you on the test. So remember, though, you do need to know the steps, the order that the steps come in. And the first step is to find f of x plus h. So we take our original function and replace the x with x plus h. Now, I can't distribute this 2 while I have this exponent here. So let's use our binomial squaring skills to multiply this out. And here I have distributed the 6 already, but these 3 terms are what I get when I square x plus h squared. And we've done it a couple of times, so I hope that you are okay with those 3 terms. Now I need to distribute the 2. Okay, now step 2 is to do the subtraction of f of x plus h minus f of x. But we know the shortcut is that all we get here are the h terms. 4xh plus 2h squared minus 6h. And then for step 3, we put h in the bottom, so it's going to be those 3 terms all divided by h, and that's going to cancel an h from each term. And there you have it. That is the difference quotient for this f of x.